You know, back in the day, of course, the idea of a defocus curve was unheard of. It wasn't a tool that we used in the clinic at all, and really is of more recent origin. But today, everybody talks about defocus curves. So, Morgan, maybe you can explain a little bit. What is that phenomenon? Is it just us old guys? We're just just not interested in these kinds of things, or weren't smart enough to figure them out. But why all of a sudden are we so focused in on defocus curves?
Yeah, I think it's really been a product of the fact that there are so many lenses and lens choices out there. There's really not a lot of ways to compare them directly, but defocus curves kind of gives us a standardized method of looking at the range that a lens may give. And we do this by putting a patient in the phoropter and then slowly clicking in various amounts of power, thereby defocusing them and simulating moving that target closer and closer. So it's a simulated test, and there are limitations with that test, unfortunately. So we can't, we don't get convergence, we don't get the true kind of accommodative effect. There's not, the pupil's not gonna get a little smaller. And so with that, it truly is simulated. So there are limitations, especially on the very near end of the defocus curve. But in terms of the kind of the middle range, it's a great way to find out, what's the landing zone of a lens, what's the total defocus or the amount of depth of focus that a lens may get. Now, there was a recent study in JCRS talking about how to measure defocus curves, and I really would encourage anyone listening to this to seek that paper out, especially as you start evaluating defocus curves on your own. There's some great ways, things to look for and things to call out on defocus curves, because you really want to make sure, because it is a standardization measure, that you're looking at them all the same way and that they're measured the same way.
Yeah. Rob, I mean, in the early days of intraocular lenses, when we only had monofocal lenses, we didn't need defocus curves. We knew what the defocus curve was going to look like. It was going to be flat along the line until we reached a point where there was intermediate or near vision being tested. So, how are those tools being applied today? Yeah. With the differences in lenses, and now we're talking more about ranges of vision. And so, why is it more important?
Yeah, I mean, it's an interesting conversation, and if I think historically, definitely from a laboratory and product design point of view, optical design point of view, our interest in the defocus curve was really about making sure we've maximized that peak in vision at zero defocus. And I've said before that a monofocal IOL by design has only one job to do, and our measure of whether we're doing that job well is to look at the optical performance at plano. But absolutely, as we have continued to evolve and innovate products, as patient and surgeon expectations have changed, we do use laboratory and bench-based methods to try and predict what the clinical defocus curve will be. It's actually a really important design criterion. We use that feedback to iterate and optimize our designs, and for that reason, it's been really interesting and in a way exciting to see the growing prevalence of clinical defocus curves, which lets us close the loop in a way and see how good we have been from a design point of view in terms of predicting what's going to happen clinically in real patients.
Yeah.
I think that's another important point, though, is that the lab-based, whether you're looking at an MTF curve or just a lab-based defocus curve, it doesn't always match the clinical outcome or the clinical defocus curve. So I think it's important to look at both.